All right, I'm going to quickly go over the test 3 free response. Just making sure that it's not connected to my headphones. Okay. So the first question here in the boxes provided, rank each of the following substrates. This test 3, this is about additions, substitutions, and elimination reactions. So those are the things we're going to be going over. Okay, so for this question, in the boxes provided, rank each of the following substrates from most reactive to least reactive in an SN1 reaction. So when I think of an not SN1, SN2. When I think of an SN2 reaction, I think this likes less steric hindrance. So it wants a good leaving group on a primary or secondary nucleophile. A tertiary won't go through SN2. So the first thing I notice here, actually before I notice anything else, is this OH. This OH right here is a bad leaving group because when it leaves, it becomes OH minus, which is pretty reactive. Whereas these BRs are BR minus is less reactive. Something that I think about with that a lot is like the conjugate acid. This base is pretty reactive because its conjugate acid is a really strong acid. So that makes it a weak base. So if it's a weak base, that's a good leaving group because it's not trying to react. It's just not, I'm just going to write LG. It's just not reactive. Good leaving groups are not reactive. But OH minus, its conjugate acid is water, and water is a weaker acid. It can act as an acid, but it's a weaker acid. So that means OH minus is a stronger base. So it's just, in general, more reactive. So the first thing I would say, I'm going to actually this was all sort of just an aside of why that's a good leaving group or not. So I'm actually going to erase everything I just wrote. So if you need to look at it, you can, but that was just running out of space there. But so the first thing I see when I look at this is this OH is a bad leaving group, while these other two are good leaving groups. So I would rank this one last. And then between these two, this is a primary leaving group and this is a secondary leaving group. So primary is the best, and then secondary is next best, and then this is the least. So then if I have to thoroughly explain why, which this isn't a skill that I've tried to really drive home this semester, I really want you to answer in complete sentences and be able to give a thorough explanation. So if I was explaining this, I think I would say I ranked the alcohol as third because OH minus is a bad leaving group. I'm just going to write LG. OH minus is a bad leaving group, which means it is not favored to undergo any substitution or elimination reaction. Between 1 and, I don't know why I put a comma there, 1 and 2, I ranked the primary bromine as 1. I don't know why I put an in there. As 1 because it is less sterically hindered than the secondary, making it the most reactive of the three. There we go. So that's how I would explain it, or something along those lines. So I clearly explained why the alcohol is third, why the primary bromine is the second, and then that leaves the secondary bromine to be in the middle of those two. Okay, draw all possible products that would result from an E1 reaction. Make sure to consider Hofmann-Zaitsev and rearrangement. Okay, so in E1, the leaving group leaves, and that leaves us with a carbocation. Notice this is still a wedge because it's sp3 hybridized. But if we undergo rearrangement, the hydrogen here on the dash could move over, and we will get this structure. I don't know why I let my little that line looks crazy. My handwriting, I'm not used to the iPad yet. We'll get this structure, and now see how there's no wedge. That's because it's only sp2 hybridized, and so it's flat. So we don't need to show 3D structure, which is what the wedge is showing, whereas sp3 is 3D because it's tetrahedral. So I just want to point that out. So once we have the carbocation, we could lose the hydrogen from any of the alpha carbons. So I'm just going to highlight the alpha carbons here. This is an alpha carbon, this is an alpha carbon, and this is an alpha carbon. Now there's also a line of symmetry right down the middle. So if I take from either, actually I'll do these in red, either of the red alpha carbons, then I'm going to get the same product. So if we take that, we would have our base, whatever it is, take this, the electrons fill in, and then our leaving group leave. Nope, our leaving group already left. I don't know why I did that. This would fill in, and we would get a the substituted alkene. That is Zaitsev product. The other option is for the base to take from, I'll do this in another color. If the base were to take from here, and then the electrons, here, let me draw the hydrogen in. If the base were to take from here, fill these electrons in, the other thing we would get is this product. So a lot of y'all got the Zaitsev product, but not a lot of you got the Hofmann with the less bulky. And that one was kind of hard to see. So each one of those were worth 1 point. Those are the two that we could get for E1. So here's my answer. And then on this question, draw all possible products that would go from an E2. So I got to get this, I'm going to do this here where we have our Br pointing up and our CH3 pointing up. So then we have our hydrogen pointing down. So one of our answers would be with between where the Br was and the CH3 was, but the CH3 is still there. Again, notice that this CH3 is flat. That is because it's sp2 hybridized, which means it's not 3D. So we don't do a wedge or a dash. So that's one side it could go from. It could also go from over here, which would give us this product. So these are the two products that would come from E2, and so that each of these was also worth 1 point. And so technically, I'll highlight the one here, the Zaitsev here, and the Zaitsev here end up being the same product, but you did have to draw them twice because I wanted to make sure you knew that one came from E1 and the other could come from E2. So it was more about like knowing the mechanism and not just the end product. I want to know the mechanism. I don't just want to know that you know the end product. Okay, so the next one, let's see. So Br2 attack, or the alkene would attack the Br2. I like to actually draw the Br out, Br like this. So you can see this. Some people draw in the back attack, but I didn't count for that necessarily. And then we get our bromonium ion where if this was substituted, there would be a strong partial positive on one side or the other, but I will just do it with partial positive on both. And then, so you get your bromonium ion and then your nucleophile attacks. It would attack on the more substituted side because this is a Hofmann, or sorry, not Hofmann. This is a Markovnikov product. But in this case, they're the same. And I'm actually going to draw this 3D structure because I think that will help to see that the Br stays 3D, and then the OH2 plus is on the dash, and then you had to deprotonate it to get the Br and the OH here. Technically you would get this plus the enantiomer, as you could also get the enantiomer of this. So I believe that the breakdown of the points was it's like you got points for curved arrows here. I think it was maybe +1 points for this. It's been a little while since I made the key. Maybe +1 points for these curved arrows, and then also +1 for the intermediate. +1 curved arrows, +1 intermediate. And then, oh yeah, we ended up grading this out of 7 instead of 6, I think. Maybe not. I'm not 100% sure. Then we also, it was +1 for the deprotonation. And then 1, 2, 3, 4. Yeah, and then we gave +1 for if you got the product Markovnikov, and +1 for it to be, oh no, not for it to be Markovnikov, +1 for it to be anti. +1 for anti, and then I also think it was maybe +1 for the right products. I can't remember exactly, but this was the main idea. So this was how the mechanism would work, and this was how the final product would look. And then the last one, we had a long discussion about this in class, about the role that science and the government play in each other. So the grade should have been 1 going each way. So 1 for the science and the government, like how does science impact the government, and then another one for how does the government impact science. Okay. Well, hopefully that was helpful to you, and I don't know what else to say. So good luck studying for your final. Let me know if you have any questions.